My name is SunDra. Today I'm going to present my thesis, a little forecasting and management using methodology with some casting platform. This research that underway my concept and early project under supervision of Mr. Nampadana and academic advisor here. Before going further, let me give you a brief on my today. I will go through the class from introduction with the description, the related study, methodology, design discussion, and finally conclusion with a conclusion. Now that we are in progress, I will the format in concept as available for research on our system. I will first the data scientist in electricity forecasting field and focus on machine learning and automation. So let me introduce this platform. So the platform for research training on our system was created by ODC, funded by AMS, and collaborated with multiple partners such as ODC, ITC, and UTA. Before going to the technical detail, I would like to give you a key concern that we can see in this chart. Cambodia's electricity demand is rising rapidly between 2010 and 2024. Then in 2021, the electricity demand is starting to grow much faster and become harder to predict. And as we know that the electricity demand is starting to grow rapidly, but it still relies on manual forecast, and this may create three major challenges. The first is data inconsistent. Manual data planning is time-consuming, it can introduce hidden error, and second, all from the data processing and modeling are disconnected, and so there are no smart web platform for ODC now. And to address that challenge, I was decided a few main goals. So my primary goal is to develop a smart forecasting model and integrate it into ODC to do a level application. And to address this goal, I have four main objectives. Then first, I want to identify the most important feature, and second, to optimize the feature set, and third, to validate the machine learning model, and finally, I want to build an interactive forecasting dashboard. And I want to highlight my project partner over the 16 leading concepts I like in parallel, and finally, my progress stay close to the plan. And before I develop my methodology, I conduct a literature review, and the most of the literature review is focused on machine learning and explainability, and I decided into four main gaps. That the first gap is many other studies focus on rely on only a single integration method, which makes a large nonlinear relationship pattern and figure out the picture of the explainability side. Many of the studies use only one explainability method, and for the algorithm side, we know that every model has its own strength and weakness, and many single models use the similar algorithm. And finally, on the evaluation side, many related study test their model only one of the data set. In order, the best of the literature review, the most of methodology was designed for developed country with the stable power system. However, Cambodia is the developing country with the unstable power system, and the electricity starts to grow much faster. And so there are no reliable framework for forecasting in Cambodia. Now we move to the methodology. So I designed the methodology based on the data of literature review and the background of the study. So the methodology, once I put to say, the first step is the machine learning pricing pipeline that begin with collecting the electricity load and weather data, followed by data processing and digital engineering. Then I apply translation method. Then I develop the forecasting model that optimize using rolling validation and hyperparameter. After I get the optimal model, I integrate it into the web forecasting platform. So let's start slavery monetization project. The target framework is the total national system work in medical art, and the federal combined the advance start from 2019 to 2024. And after I graduated the advance, I performed the physical engineering grading by grading picture, rolling sunset, the picture, and then you indicator weather. And here is the time after this. So instead of relying on only one physical selection method, I developed a three-stage physical selection. It's called multi-stage hybrid physical selection framework. And the first stage, I apply the optimal correlation and neutral information. And the second step, I apply the model-based learning, communication important, and sharp important across similar numbers, individuals, and marking. And the third step, I optimize them using the experimental design and test the data from our group. And finally, I get a final group that optimal and best for 48 hours long state. After I get the optimal data, the next step is to develop a focusing model. I use the random forest, vegetables, SEO, and RP, then optimize them using research. And for two another I use the linear regression and molecular regression. And here is the full view of the meta-state interval learning model, starting with the training, visual engineering. Finally, I get the final success group. Then I say using for it's called rolling visualization. Then I actually using hyperparameter. Then the prediction from that model, and then combine to create a meta safety and asset. And it can also input for two meta learner, linear regression and molecular regression. And finally, I evaluate them using the mean absolute percentage error and mean absolute error with the anti-2024 data set. After I develop the optimal pricing model, the step is to deploy the model into the web application. So this application is time to for message. The first layer is the first layer is the presentation layer, provide a user-friendly interface. Also, my user, the API layer, handle the communication between focusing model and the web application, and the machine learning layer perform the visual engineering and training on our data safety model. And the data layer store the data upload and user information. And in overall, the platform also supports the full domain of the data upload, data validation, visual engineering, and model inference, and the forecasting result. And that can allow user can upload the casting result of Excel or CSV. To ensure the application is reliable and easy to maintain, I use during the development, I use the code and automate CI/CD to making deployment is more efficiency. And for CI, I use GitHub Action, and the CD I use automation to deploy all the local server for the first day. And finally, I test it by using unit test. And as a result, the platform now is ready to for the knowledge without using for a research. After discuss the methodology, now let's move to the result. Starting with the baseline translation result, you can see that three methods. You can see that no single translation method based on every machine learning model. Based on this observation, let's propose me to propose the one-stage every translation framework. And this framework reduce the number of features from 66 to just 19 and keep the performance. And now that one add four base model and two meta model with the anti-2024 data set of potency indicable. The meta linearization achieve the best performance in overall with the lowest mean absolute percentage error of its frequency. than 1 week after forecasting, you can see that the meta regression is closely related to the actual value and can capture the peak load and the overnight period. And now to discuss the result. Based on the experiment, I can say that every single feature selection method has its own strength and weakness, and different methods different things. So the cost of hybrid feature selection framework can use a number of features and also optimize the training cost and the complexity, especially based on the requirement. And for the feature side, the feature engineering, such as feature is very important to predict the electricity load. And finally, the cost of meta-stating model is actually the best performance in overall and better result, better than the single model. Now it's time to conclusion, and I want to reflect to my core objective. And now I'm pleased to say that all my objectives are achieved. And this project is not contribution on the technical detail, but it's also contribution to the sustainable development goals for both and clean energy. And beyond the technical detail on this project, I did some challenge that when I perform the feature selection and feature requirement, and I run it parallel, it affects to my timeline. For example, in hyperparameter tuning, I took longer than expected. And to complete this project, I also learned from the hard skill and soft skill. From my technical perspective, I strengthen my machine learning model, visual selection, and know how to apply the data for the real world application. And for my personal perspective, I improve my learning ability, problem solving, how to communication with the team, and time management. After achieving this goal, I also have 5 future directions. First is expand focusing horizon from project hour to longer, better for planning, and second to explore the learning model. Third to automate performance monitoring and automate the real-time data and open the API and upgrade the user-friendly platform. And these are my reference. And I would like to show you my short demonstration. So user can upload and data to the platform. Then the system will validate data, and then user can pick the specific 48 hours for the prediction. Then it will use the result, and the user also can upload the Excel or CSV. And this is some of the model training, user management, and user can upload the last version of the model and just activate on the platform and can use the final model. Now that concludes my presentation. Thank you for your attention, and I'm happy to answer any questions if you may have, and any suggestions or recommendations. Thank you.
Okay, thank you for your presentation. Now, let the conversation for the three start on the class. Is very interesting because this research
question is, during your data collection or data collection and data cleaning, is there any challenges concerning data cleaning? Because when we look at your overall statistics, and the data across many years, it's a challenge.
For the data collection and the marketing, I get the data from my supervisor. And mostly the data is prepared for I apply that for the from physical engineering and visual station.
So the data is already there. For my question, so let's move to
So I have two questions now. The first was the presentation. The first question is that you say somewhere that is from your literature review or in the case of the literature review, you see that the ensemble model and mostly use the same or similar model. So in your project, how do you address this game or how do you address this game?
Thank you for a very interesting question. Many of literature review use a similar method. For example, this one paper. The first paper is use the data set from 2019 to 2024, and they use only the random forest statistics in the three model, and not include the interleaved model like the type of OMP or SDM. And based on this map, I include the OMP and SBR with a base model, and this OMP model can handle the nonlinear relationship transfer. So after I apply the base model instead of two model, the performance better than the existing study.
And another question, you were saying regarding feature selection, you use Pearson's correlations. Can you tell me more about how you manipulate it?
For the Pearson correlation, I use the Pearson correlation greater than 50%. Then I keep all feature and then I apply the use redundancy greater than 95%, and I add 50% baseline feature.
I mean, in this, if you have presented those features, what are those features that you have in your hands? Like the feature that you study with correlation.
Before study.
Like the feature that you follow, what are those features where you have
for the total feature, I have 19 feature, and I don't show it here. It includes weather feature, temperature, VO, and lake feature, rolling time feature that include the 48 hours, and it's 14-day feature, and few feature that come from the weather and temperature. Then I not do weather or.
Okay, so because like your data is like ancillary data, so I just wonder how you use essence quotation to calculate the essence quotation. Yeah. Thank you for your answer. That's all for me.
Okay, thank you, Alex. I think Sukhir is your advisor, so Sukhir will be collaboration or maybe question beside technical question as advisor, suppose that we check everything. I'm also saying there's a lot of technical work that I'm not that good at, but I'd like to general think about your internship. One great office for me and maybe for all of you also, the topic is not, I think, very popular topic, but it's not new. As you know, for the UN, it is highly studied, especially in developing countries like our country. So, my first question is concerning to your topic, what is the smart forecasting platform language? This is your answer to just the last one.
It's called the smart forecasting platform because the now is not yet the qualification that have the final model based on forecasting. Then there are now the forecasting platform now, and this is the first application for the early stage and for development.
So you mean the one that you just said?
Yes.
Okay, so yeah, this is the second question, and I hope that there's no more question for this time. Do you recommend your results to your supervisor in the company, particularly in the business? Your result after you obtain some result from internship, and also after you develop your platform, do you recommend to them?
Yes, I recommend to them, and this internship is like it's a kind of like a project, and for my recommendation, I recommend him to develop a view from the smart forecasting platform by use the separate tree forecasting model, and instead from coding our to notebooks for the planning. Yes.
So last question, no more question, but just a comment. So you feel like you can choose to work at least a protein and consideration of because you are hiring person or staff. So then you severe or automatic calculation. So it's only one meeting. And so yeah, if you have any questions.
Question. Why do you see the feature exception very important? Feature exception. Feature exception before primary.
For the feature section, because from the weather and solar and it have a lot of feature. It's around 151 feature, original feature, and after I apply the feature selection, it reuse the feature from to the Thesis and 19, and it's very important for this variable requirement, and the fewer feature is easy to maintain and improve the forecasting accuracy.
I have only half a minute, but I want to say congratulations. This is the end, and I hope you keep working hard and improve yourself. But you did a good job. Thank you.
Thank you very much.